Okay, we're now on page 3 of our notes. Here we have an example. Consider the following game. You roll a single die. If you roll an even number, you gain that number of points. And if you roll an odd number, you lose that number of points. So we're asked to list the probability distribution in tabular form, to draw the probability distribution graph, make a decision as to whether or not this is discrete uniform probability. What is the expected number of points per roll? And is this a fair game? Why or why not? So in the first index, so this our value of I, that's going to be our first value that we're considering. Let's assume that I roll a value, a die value of 1. So we're told that if it's odd, we're going to lose that number of points. So a roll of 1 would give us a yield of -1. In our index of 2, that's also going to correspond to a dice roll of 2. We gain that number of points, so that's going to be a +2. Our third index value would be a roll of 3, odd number, so we're going to lose that number of points. A roll of 4, or our index of 4 would give us a yield of 4 on our dice, and that will be a +4 because it's an even number. Our fifth index term, the roll would be a 5 on the dice. Odd number yields a negative value of that number of points. And then our sixth element is going to be a roll of 6, an even number, so I'm going to add that number of points. Again, I'm rolling a dice, so assuming that the die is not weighted, then that would give us an equal number of, it should be a uniform probability. One moment. Is that not working? All right, sorry about that, guys. Where are we? So assuming that these die are not loaded, then it's going to have an equal probability of each of these outcomes. So our probability of rolling a 1 is going to be a 1 in 6, a 2, a 1 in 6, a 3, 1 in 6. Each of these instances, we're expecting a 1 in 6 probability. So that ticks off the probability distribution chart. We're now looking at the probability distribution graph. Again, I'm going to label my graph. I'm going to give this as my probability of rolling a die. So this is my probability of X on the Y-axis, and this is going to be the value of die on my X-axis. So I'm going to have a possible value of 1, a 2, a 3, a 4, a 5, or a 6, and 1, 2, 3, 4, 5. Possibilities of 1 over 6 and 2 over 6. And because this is uniform probability, in each instance, I have a 1 in 6 chance of rolling each of these die. And again, just to make it easier to see, I'm going to connect these points. So that's our probability distribution graph. That's what part B was being asked for. Now we're being asked, is this a discrete uniform probability? Well, is it uniform? Absolutely. Our values are all the same, so we know that it's uniform. Is it discrete? So remember yesterday we took a look at the terms discrete and continuous. Continuous, we would expect to see decimal values, a continual spectrum of answers in between all of the values. And in this case, that's not the case, so it is most definitely discrete. So yes, it is discrete uniform probability. Explanation for that. So C, yes, it is uniform because all outcomes are equally likely. And yes, it is discrete because all values are integers. All outcomes are, yes, discrete. All values are integers.
Good morning, Holy Cross. I want to wish everyone who's writing the OSSLT today good luck.
And finally, well, D.
And I'm going to ask that everyone now
looking for the expected value,
where they need to be to begin the day. So for those of you that are writing the OSSLT, you are moving now to room 108, 109, 110, or to the Learning Commons. Those of you that are in grade 9 should now proceed along with your homeroom teachers.
So in this particular case,
to the gymnasium.
expected value
All
of
grade numbers
1
and their homeroom
has
teachers to
a,
the
sorry,
gymnasium at this point.
of a -1.
And any grade 10s that are not writing the OSSL.
That's the value of our
should
x.
proceed at this time to the calendar.
We have a 1 in 6 chance.
Good luck.
The possibility of getting +2 points, right? +2 is a 1 in 6 chance. Possibility of getting -3 points, it's going to be -3 times 1/6. Possibility of +4 points is 1/6. Of -5 points, 1/6. And +6 points is 1/6. When we do all that, we get -1, +2, -3, +4, -5, +6. It's -4, -9, -4, -9. Gives me a value of 3, I think. 3 out of a total of 6, or 1/2. And so finally, the last thing we're being asked for is this fair? A fair game is determined if the expected value is a 0. So this is not fair because the points gained and lost are not equal. In a fair game, our expected value should end up being a 0, so that the negative aspects counteract the positive aspects. So that's something new that we've seen that we've not seen. There's a note about it in the text. You can read up a little bit on fair play, but that's basically what we need to know for a fair game to take place. Our expected value is going to be 0. And then the last question is, I ended up doing that yesterday in class. So you can check yesterday's note for solution to that if you need to. And suggested homework is listed here. Finally, remember tomorrow, Friday, is a non-uniform day. We'll see you guys then. Hope you enjoy your day working from home.